So hello dear students, good evening all of you. So in the previous session we were discussing regarding the stability of the induction machine, correct? So now we'll start our discussion, that is the testing of the induction machine and the losses of the induction machine. Okay, so already I have told you your induction machine is just an transformer. Induction machine is a rotating short circuited secondary transformer. Induction machine is a rotating, but it is having short circuited secondary, and it is a variable frequency machine just because of slip. Okay, just because of slip it is a variable frequency machine, correct or not? So already we have discussed the stability of the induction machine. Also I have given you an assignment question. So tell me, in that assignment question, which option is correct? All of you got the correct answer or not? Tell me. All of you got the correct answer. And till now we have, and today's session, we discuss the torque slip characteristic in the morning, and in the afternoon we discuss regarding the stability. So far you have, so till now, any doubt so far? So what we have discussed so far, any doubt? Tell me. Any doubt? Otherwise we'll jump to the very next session, next topic, next subtopic, that is the losses of the induction machine. So write down the heading, the losses in the induction machine. Okay, write down the heading, losses. So this is very small topic. Of course we'll discuss in a very briefly, we'll discuss. Already we discussed the losses in the transformer. So basically losses means what type of losses are there in transformer? Recall it, tell me. So there were basically the copper losses and iron losses. Copper losses is due to the winding in the core, and the core loss or iron loss is due to the core material used, the core magnetic material used. Okay, so these are the basic losses in the transformer. I am talking about major losses. So major losses in the transformer was the core loss and the copper loss. So core loss is nothing but your core loss depends upon the flux, and you know, in case of transformer it operates at constant flux. So if flux is constant, then obviously the core loss inside the transformer will remain constant. Similarly, the copper losses depends upon, copper losses, you know, it is nothing but your I square R losses or ohmic losses. Since it depends upon the current, and current depends upon the load, and you know, load is variable. So if load is variable, then current will variable or not? Yes, the current will be variable. That's why the copper losses is regarded as the variable losses. Till now everyone is clear. Just I am recalling about the transformer losses. Now come to the induction machine losses. So already I told you, your induction machine is just a transformer, but it is a rotating transformer having short circuited secondary. I repeat, your induction machine is a rotating transformer having a short circuited secondary. So obviously in this case also, here mechanical load is there. Mechanical load will be coupled to the shaft of the induction motor. So obviously here also core is there, and due to variable mechanical load it will draw variable amount of current. So in this case also the copper losses and core losses will be there. In this induction machine also core losses and copper losses will be there. But tell me, what is the additional loss in case of induction motor? Obviously the additional losses, that is the third losses, must be due to the rotating mechanism, correct or not? Previously, you know, transformer was just static, it was at rest at any condition. So in case of transformer, just two losses were there, those were the copper losses and the iron losses. But you know, induction motor is a rotating device, or it is a rotating machine. So the extra losses, those third losses, must be due to the rotating mechanism. So can you tell me what is that third losses? Now solely we'll discuss about that third losses, because already we discussed in detail regarding the copper losses and the core losses. But tell me, what is that third losses in the induction machine, copper losses, core losses. Now tell me that third loss. And already you know that how to find this core losses, how to find this copper losses. We find the core losses and copper losses by performing the testing or not. In case of transformer, I have to find the iron loss. That means I need to perform the open circuit test, correct or not? Similarly, in order to find the short circuit test, in order to find the full load copper losses, I need to perform the short circuit test. Similarly, these two subtopics, losses and testing, always interlinked. I have to perform the test, then only I'll get the value of iron losses and copper losses. So always the losses and testing are interrelated, correct or not? So tell me the third losses. Tell me those third losses. Yes, obviously those losses are called your mechanical losses. So the third one is your mechanical losses. Mechanical losses. So this mechanical losses is nothing but it also categorized into two parts, just like core loss. Core loss means it is the hysteresis losses plus the eddy current losses. Similarly, mechanical losses is subdivided into two parts. Okay, two parts. One is your windage losses and friction loss. Windage and friction loss. So can you tell me what is the meaning of windage losses? So can you tell me what is the meaning of windage losses? What is the meaning of windage losses? See, in the induction machine, two parts are there. One is starter, another is rotor. Okay, got the point? Starter is there, rotor is there. So there must not be a physical connection between the starter or rotor, correct or not? There must not be a physical connection between the starter and the rotor. Otherwise, how rotor will rotate? Tell me. It is not at all possible. So there must be a separation between your starter and the rotor. That separation is nothing but your air gap. I repeat, that separation is called your air gap. Air gap, correct or not? So if air gap is there, then don't ignore the power, then don't ignore the losses happened due to the opposition of this air gap. Don't ignore the losses happens due to the opposition offered by this air gap. Suppose in linear motion, this is your road and here a bus is running. Okay, suppose this one is your Volvo bus. It is running at 90 km/h. 90 km/h, kmph, correct? So if it is running at 90 km/h, definitely it has to overcome the air or not? Yes, it has to overcome the air, and it is of course a linear motion. It is linear motion. So it has to overcome the air opposition. If it will run at 90 km/h, obviously air will oppose it. So obviously we have to do some mechanism in order to reduce this air friction, not friction, air opposition. Air opposition. That is also obviously some amount of power will be losses due to air opposition. This is for linear motion, correct or not? So what we have to do? You have to do some mechanism. You have to reconfigure your front size. Then only air losses will reduce. Now come to the induction motor. So in case of induction motor, rotor is rotating in the air gap. So what we have to do? And you know, windage losses is due to the air present in between the starter and rotor. The air present in between the starter and rotor, it opposes while running. It is the opposition offered by the air present in between the starter and rotor. That is called your windage losses. So can you tell me, if the air gap increases, then windage losses reduces or increases? This is my first question. What is the relation between the windage losses and the air gap? If air gap length increases or air gap length decreases, what is the impact on the windage losses? This is my first question. And second question is that what is the relation between the windage losses and speed? What is the relation between the windage losses and speed? So, what is the relation between windage losses and speed? This is my first question. And second question. My first question was, if the air gap length between the rotor and starter increases, then will there be any impact on the windage losses? That is my first question. Correct or not? Tell me. Losses due to wind present in air gap, correct? So loss due to wind or air, that is leakage. Okay. So in summary, I want to tell you one thing. If the air gap length between the starter and rotor, simply air gap means it is the gap between the starter and rotor. No need to mention that it is the gap between starter and rotor. So anyway, air gap means the gap between the starter and rotor. So if the air gap increases, the windage losses increases. So directly proportional to the air gap. Now come to the second point. So windage losses of course depends upon the speed. It of course depends upon the speed, but it is not directly proportional. It is proportional to speed to the power 3. It is directly proportional to speed to the power 3. Okay, this is all about your windage losses. So now come to the friction part. So of course, if a bus is running in your road, if a bus is running in the road, obviously some friction will be there. Where the friction between where? So can you tell me what is the friction in when a bus is running in the road? So in this case, for linear motion, the friction is in between the tires of the bus and the road, surface of the road. In between the tires of the bus and the surface of the road. Okay, the friction will act in this direction, in between the tires and the surface of the buses. Now can you tell me what is the friction losses in the induction motor? What is the friction losses in the induction motor? So there is a friction, you know, in order to smoothen the rotation, ultimately I have to rotate the rotor in the axis of shaft. Okay, suppose this one is the rotor body, I have to rotate the rotor in the axis of shaft. Correct or not? So in order to, so there must be a physical arrangement between the rotor body and the shaft. So in between the rotor body and this shaft, there must be some balls and bearings. Balls and bearings are present everywhere. In your induction machine, in your bicycle, in your wheels of any vehicles, In order to smoothen the rotation, there must be some balls. Correct or not? So balls and bearings arrangement must be there. So write down the friction. So where the friction occurs? In the balls and bearings arrangement. In the balls and bearing arrangement. And next point is arrangement. Now write down the next point. Next point is there must be a friction between the, see, in case of slip ring induction motor, there is a brush and there is a contact between the axis of the shaft and the brushes. So brushes is fixed, but your shaft is rotating and it is connected and there is a connection between your shaft and the brushes. So there must be a friction between your brushes and the shaft. So the third friction losses is between the brushes and the shaft. That is called your brush friction loss. So balls and bearing losses, where it occurs, Now write down the brush friction losses. Brush friction losses. and brush friction losses is due to the contact between your brush and the shaft. I am talking about your slip ring induction motor or wound rotor induction motor. I am not talking about a squirrel cage induction motor. Getting my point? In order to increase the starting resistance, I have to add some external resistance. So external resistance are connected to the rotor parts of the induction motor through the brushes, and brush is in between. The brush is of course the static part. In the brush, contact leads has been connected, but brush is a static part, but your shaft of the induction motor is a rotating part. It is a movable part, correct or not? So there is a contact between your brush and the shaft. Okay, so let me summarize once again. So in case of induction motor, core losses are there, copper losses are there. You know, core losses is a constant loss just because we have to maintain constant flux in the air gap. We have to maintain the constant flux in the air gap. And you know, copper losses is variable loss, because if we calculate the mechanical equivalent of the electrical losses, so mechanical losses is varying. It means the load is varying. It means the equivalent electrical power must be varying. So current must be varying. So it is comes under the categories of variable losses. Now come to the mechanical losses. So mechanical losses is basically categorized into two types. One is windage loss, second one is friction loss. And you know, windage loss is just because it has to overcome the opposition offered by the air gap. It has to overcome the opposition offered by the air gap. Now come to the friction loss. So in any rotating machine there must be a balls and bearing arrangement. So this friction loss is due to the balls and bearing arrangement, and second one is the brush friction losses. All this terminology already I have explained to you. Now my question is that whether these mechanical losses are constant or variable. Now my question is that whether these mechanical losses are constant or variable. क्या हुआ? ये नहीं आ रहा है, कुछ प्रॉब्लम है क्या? बुलाओ बुलाओ जल्दी, क्या प्रॉब्लम है?